Hello friends, in this lecture we are going to learn about a media access control protocol that is known as CSMA CD. Okay, so what it means? It's carrier sense multiple access plus you also provide the feature of collision detection. Okay, so we had carrier sensing. Okay, that was the first good thing that we brought. Okay, so simplest one for multiple access is aloha. Okay, so A, B, C and D, let's say they are on a Ethernet wire, they are all connected through that medium, and in simple aloha or pure aloha anyone has data to send, so they will transmit without sensing if the channel is idle or busy. And now what happens if, let's say, A starts transmitting when it has data, and if C was already transmitting, then there will be collision. Okay, and both the frames will be destroyed. Okay, so here the problem was we were not sensing that if the channel is busy or idle. Okay, so carrier sense brought the idea that now before transmitting, let's say A has data, now this is the channel. Okay, so before transmitting it will just check that is someone else sending something on the wire. Okay, and so they sense the channel and find if it is busy or not, and if it is not busy, so the node sends data. Okay, so still carrier sense has a problem, that the thing is that when you transmit bits, okay, so it takes time. So I transmit a frame, it will slowly move, like not slowly but it will move like this. Okay, so it will be moving, and let's say the bits from A have moved till here when C senses the channel. So these bits have not come to C yet, and he senses the channel to be idle, so he will start transmitting, but then his bits will collide with that of A and there will be collision. Okay, so carrier sensing helps, but still there is a chance of collision because the bits are signals that take time in traveling, even though they are traveling with speed of light or something. Okay, but they still take time, and if you sense in between that, then there will be collision. So what collision detection does now is that it even tries to avoid these collisions. So what happens? So here they are showing this is the time axis and this is the distance. So at t1 time, so first bit of A is transmitted. Okay, so it's traveling like this. So distance is traveled is this much and time taken is this much. Now let's say that at time t2, so where is your at time t2, so A's signal has only traveled till here, this point. So C senses the channel and it is idle. Okay, because at this moment your A has only traveled till here, so C senses the channel, it's idle, it starts transmitting. But in time t3, so this time A's signals come here and it collides with C. So what will happen? Now the collision takes place at t3, so its transmission time was t3 minus t2, and then these signals from C will travel, and at t4 it might reach A, and then there will be collision. Okay, so the collision is detected by the node. Okay, so it cannot be detected in between. That's why, so these bits from C will be starting traveling at time t2. Okay, and when only these signals travel this whole distance and reach A, so A will detect collision. So this collision detection also keeps on happening. Okay, it means that while I am sending, I will also be detecting collision. Okay, so it will be a kind of loop while you are sending. So in fact you detect any collision. Okay, so we are detecting collision too. Okay, so this is happening. So I'm sending, and at the same time I'm seeing if any collision is there. So what will happen in the worst case? So worst case, what will happen is I and A and D are, let's say, the farthest two nodes on the LAN. Then A starts transmitting, and let's say it takes TP time, okay, propagation delay from A to D. So now if, let's say, when it was just reaching, D senses the channel, okay, so now what will happen? He will find that, okay, channel is idle, and he will transmit, and there will be collision, and it will be detected only at 2 TP. Okay, so this is the vulnerable period. Okay, so if we move forward, so let's try to see. So now what happens? Okay, so this we have already done. So this one, so collision occurs, and this is the part of the frame. So this was transmitted for C, and so C detects collision and aborts first. So first C detects collision, and at T4 A also detects collision. Then so let's try to think about one problem to clear our concept. So a network using CSMA CD, okay, so it uses CSMA CD, has a bandwidth of 10 Mbps, okay, so it can send data at the rate of 10 megabits per second. If maximum propagation time is 25.6 microsecond, okay, so from A to D, the farthest node, let's say this is the maximum propagation time. I start sending here, the signal travels and it takes 25.6 microsecond. What is the minimum size of a frame? So now let's try to understand this concept of minimum size of a frame. So A sends the frame, okay, it will take 25.6 microseconds to reach the other end or the farthest node. Now what we said is that in collision CSMA CD, so while A is transmitting, it is also detecting collision, and when it detects that, okay, whenever it was sending and it detects, so let's try to see one more thing. So when I come here, okay, so when, let's say, C was sending, and whenever he sees that, okay, there is collision, so let's say frame takes 5 microsecond for transmission, and only after 2 microsecond of transmission, C finds that, okay, there was collision, so it will not now send the rest of the packet, which will take another 3 microseconds to transmit, because it has already detected a collision. So we are here, so it takes 25.6 microsecond to the propagation delay. Now A, which is sending the frame, can detect collision only when it is still sending the frame. If it has sent the frame and after that somehow, let's say, the propagation delay is very large, okay, so what will happen? I have a frame that just, let's say that it takes only 30 microsecond to transmit. Now what will happen? My first frame bit reaches here at 25.6 microsecond, and last frame, what will happen? 30 microseconds are taken for transmission, okay, transmit that frame. Now what will happen is that 25.6 microsecond is for traveling time, and 30 microsecond I was transmitting, so total it will take 30 plus 25.6 microsecond, so it will take how much? So it is around 55.6 microsecond. In that, all of the bits will reach D. But let's say what happens is that there is collision, okay, when the transmission was, so what will happen now? all the frames, the last bit of the frame will be sent as at 55.6 microsecond. Then what happens is that then also, if you think, when it receives the first frame which was at bit at 20.6 microsecond, now if there was a collision, it will take another 25.6 microsecond for the error collision to reach A. So it will be, total will be how much? So it will be around 50 microseconds. So in that case, I can detect collision because I was still transmitting. But let's say if my frame time was only 10 microsecond, then what will happen? So when after 30 microsecond here, what happened? I stopped sending the frame, but my first, this total will, so I stopped sending the frame at 30 microsecond, but this collision will reach me at 55 microseconds. So it means I will not be able to detect that. So it means that your frame size should be minimum twice of propagation time. That much of time it must take to send a frame. So this will decide your minimum time. So why? Let's try to see this concept again. So A and B are two farthest frame, okay, and this sends, this takes TP amount of time. Let's say the whole frame takes me TF amount of time. If TF is less than twice TP, what happens? So I have collision, okay, so I will, let's say TP was what we took, it is 25 microsecond and my TF was just 30 microsecond. So at time t is equal to 0, I start transmitting, okay, t is equal to 0, start, and then what will happen? At t is equal to 25 microsecond, first frame will reach here, first bit, and what will happen is last bit will reach here at 30 plus 25, 55 microsecond. But let's say I will stop sending, A will stop sending the bits at 30 microsecond. Then he will not be detecting if there is a collision. And let's say there was a collision even in the first bit. So to reach again here, it will take 25 microseconds. So it will start, the signal will come here at 25 microsecond. Collision will be detected at 50 microsecond. But now A is not sensing the collision. So for detection, it should be still sending the bits of the frame even after twice TP, for minimum twice TP. Okay, so this should be your minimum time of the frame. If B is the bit rate, so B bits per second, okay, and your time is this one, so this will be your minimum frame size, and that's what we were discussing. So TFR, the minimum transmission time, should